You know how sometimes in math you can follow all the steps, you get the right answer, but you're kind of left wondering, wait, why did that actually work? Well, you're definitely not alone. And today we're going to fix that for one of the biggest topics in algebra, quadratic equations.
So here's our game plan. First, we'll cover what a quadratic even is. Then we'll solve one together, step by step, no skipping. After that, we'll do the all-important check, look at some common exam traps to avoid, and then finally, we'll get to our final answer. Let's dive in.
All right, first things first. What in the world is a quadratic? Because before we jump into the how of solving them, we really need to get the why behind them.
And really, this is the whole point, isn't it? When you move past just memorizing rules and start to understand the logic, that's when math really starts to click. And that's exactly what we're going to do today.
So at its heart, the definition is actually pretty simple. If you look at an equation and the highest power of your variable, usually x, is a 2, you're looking at a quadratic. That's it. This general form you see here, ax squared plus bx plus c equals 0, that's like the blueprint for pretty much every quadratic we're going to see.
Okay, but what's the goal? Why are we even solving these things? Well, we're on a hunt for the specific values of x that when you plug them in, make the whole equation equal 0. We call these special values the roots or the solutions.
All right, theory's great, but now it's time for the main event. Let's actually put this into practice and solve one together. And I promise we're not going to skip a single tiny step.
Here's the problem we're going to tackle. X squared plus 5x plus 6 equals 0. This is a real classic, and it's perfect for showing how the whole process works from beginning to end. But hold on, before we even think about touching the numbers, we have to talk about this. It's a step that almost everyone does on autopilot without asking the most important question. Why? Why does it have to equal 0? And here's the answer. The whole method we're about to use, called factoring, it only works because of something called the zero product property. And for that property to kick in, the equation absolutely must be set to 0. This isn't just a helpful tip. It's a critical rule of the game.
Okay, so what does this word factoring actually mean? Well, think of it like a little number puzzle. We're looking for two magic numbers, and these numbers have to do two things at once. First, they need to multiply together to give us that last number in the equation, the positive 6. And second, they need to add up to give us the middle number, the positive 5. So let's think. What numbers could do that? How about 2 and 3? Let's check it. What's 2 times 3? It's 6. Perfect. That's the first condition met. What's 2 plus 3? It's 5. Yes, that's the second condition. We've found them. Our numbers are positive 2 and positive 3. Awesome, we've found our numbers. So now we can take our original equation and rewrite it in this new factored form. It becomes x plus 2 times x plus 3 equals 0. We've just turned that complicated-looking expression into a simple multiplication problem. And this is where that zero product property I mentioned earlier comes into play. It's really just common sense. Think about it. How can you multiply two numbers together and get an answer of 0? The only way is if one of those numbers, or maybe both of them, is 0. There's literally no other way. So that powerful little rule lets us do something amazing. We can take our one equation and split it into two much simpler ones. It means either the first part, the x plus 2, has to be 0, or the second part, the x plus 3, has to be 0. Now all we have to do is solve these two tiny problems. Okay, we have our answers, or at least what we think are our answers, but we are not done. So many people skip this next part, but it's probably the most important step of all. This is how you prove, without a doubt, that you nailed it. Solving those too many equations gives us x equals -2 and x equals -3. Now for the moment of truth. Let's plug them back into the original equation and see if they work. Let's try x equals -2 first. -2 squared is 4. 5 times -2 is -10. So we have 4 minus 10 plus 6, which is 0. It works. Now for x equals -3. -3 squared is 9. 5 times -3 is -15. So we have 9 minus 15 plus 6, which is also 0. Both are correct. Confirmed. Now let's talk strategy. It's one thing to know how to do the math, but it's another thing entirely to know how to avoid the common mistakes that people make when the pressure's on. This is the insider's guide to not losing easy marks. Here are the top 3 traps. Number 1, forgetting to make sure the equation equals 0 before you start. It's the foundation of the whole method. Number 2, simple sign errors. It's so easy to mix up a plus or a minus when you're rushing. And number 3, skipping the final check. Not only does it catch your mistakes, but get this, some exams will actually give you points just for showing that you checked your work. Don't throw those points away. So, after understanding the why, carefully working through the how, and dodging all the common traps, we finally arrive at this moment, the final, confident answer. And there it is. The solutions are x equals -2 or x equals -3. That's it. This is what you write down, put a box around, and feel really good about because you know it's right. So we didn't just find an answer. We actually understood the entire journey to get there. And that really brings us to one last question for you to think about. Now that you've seen the logic behind these steps, what other math rules have you been following all this time without ever stopping to ask why?